Kirchhoff's laws. So it's a very important to learn because uh, whatever the electric circuit problems are there, if you want solve, it is very key step to understand. For example, Kirchhoff laws. These Kirchhoff's laws, we have two. One is regarding the current. One is talking regarding current. Second one is talking about voltage. Second one is talking about voltage. So if it is talking about current, we say that Kirchhoff's current law. That's why it is simply calling as Kirchhoff's current law, KCL. Then it is talking about voltage. That's why we are simply saying Kirchhoff's voltage law. So first of all, when it applies, what it says, we have to understand. For example, in mechanical system, suppose if you want to find the balancing, and what is the weighing machine balance, okay, weighing, not digital, just a weighing balance. So how it works, we know that very well. It's about laws of movement, right? Laws of movement. So whatever the movement about that point, so if you know, we can understand how they are balanced. Similarly, in electric circuits, suppose this current law is valid at the junction only. So we have to understand at the junction. At the junction only it is valid. Now voltage law, whenever we are talking about, it is talking about in a loop. In a loop. So if there is a circuit, total in circuit, what is being there, voltage, regarding that only it is applicable. In case of Kirchhoff's junction law, for example, the current has the dealing with, so it is dealing with in and out. It is talking about it is in and it is going out here. Whatever the currents are in and out, we have to take. So simply, what is the Kirchhoff's voltage law, or whatever Kirchhoff's current law says, it is talking about algebraic sum, right? Simply to say, algebraic sum of current is equals to 0 at a junction, or net current at the junction is going to be 0. It is a junction. At the junction, wherever three are, any number of lines are connected, whatever the input current is equals to output current. Then if you do algebraic sum means add the quantities, physical quantities with their sign. Suppose ఇక్కడ మనం ఒక సైన్ ఇస్తాం. ఇన్పుట్ అవుతున్న కరెంట్కి ప్లస్ అనుకుంటే అవుట్పుట్కి మైనస్ అనుకున్నాం అనుకో. లెట్ us say it is a I1, I2 and I3. Then what we call it? Algebraic sum of current at the junction is equals to 0. Give the sign convention for it. What is the input current? Plus I. And what about remaining? We are going to give it minus I1, minus I2, minus I3 is equals to 0. It is going to be 0. Then if you do that, I is equals to plus of all the values, just I1, I2, I3, right? What you are getting? Algebraic sum of current is equals to 0, or net current at the junction is going to be 0. So with this, whenever at the junction we are dealing when solving the electrical circuits, easily we can apply this formula, and with this unknown currents we can find, right? So similarly, in a loop, so what is going to be the net voltage? It is again net voltage is equals to 0. Net voltage is equals to 0, or in another sense we can say that algebraic sum of voltage is equals to 0. So whenever we are saying that, very important thing is sign convention. If you know sign convention, then only algebraic sum of voltage 0, algebraic sum of current is equals to 0, that we can make it very effective understanding. Otherwise it is incomplete. So what is the net voltage? Why we are talking about net voltage? Because there can be sources of potential difference and there can be consumptions of voltage, right? If there is a resistor, what we say that resistor is not giving potential difference, but instead it is using it or it is consuming. In another term, simply we can use voltage gain and voltage loss, because wherever it is being voltage or potential difference is being as a source or cause for having the potential difference, we are giving one sign convention. Whatever voltage loss or potential difference consumption is happening, there we are going to give another sign convention. So these Kirchhoff laws, net current is equals to 0 at the junction, net voltage is equals to 0 in a loop. Suppose if you take a simple circuit like this, how many voltages are there? Seems to be the potential difference here, it is okay, but wherever R resistances are there and current is flowing, from the Ohm's law we can write V is equals to I into R. So if we find that I and R values to be there, can we say that as a voltage? Yes, we can say it as a voltage. So that's why here whatever voltage is there, V1, here it is whatever voltage V2, then can we find it whatever current is flowing here in it at the resistor R1? If you know it, you can find I into R1, I into R2. If you know that, you can find V1 and V2. So then what is going to be the net voltage in the circuit? Net voltage in the circuit, what you are going to write? So for that, whatever here V equals to V1 plus V2. V equals V1 plus V2. The net voltage is going to be 0 in a loop. But apart from this, exactly what other sign convention we can follow, that's very important to take it. So what is that? We will see that in a next video. Thank you.